Hello, today we're gonna learn about functions. So this is the agenda for this presentation. First, we're gonna learn about why do we need to implement functions. And then we're gonna learn about input parameters for defining functions, as well as return values, and the stack of calling functions, and also learning about default parameters. And if we want to provide flexible arguments, then we should use star argument and star keyword arguments. We also cover about error handling and function design principles. Okay, a function is a sequence of statements which perform some kind of task. So why do we use function? Because we want to eliminate code duplication. And when we want to define function, we use def keyword. So we're gonna have def keyword and then follow with white space and then following with the function name. And the function name should start with a verb. And if we have multiple words, then we should separate each word with underscore. And then after the function name, then there should be parentheses and then colon. And then after that, then we're gonna have the code inside function block. And function won't be executed if we don't call the function. So from this sample code, line 1 and 2 is the line that we define function. And then line number 3 is the line that we call function. When we call function, we need to uh, call with function name and then also have parentheses. Here, after we execute this code, then it will uh, go to the statement inside this function, which is print hello world. And that's why we get the output hello world. Okay, we need to choose a function name which explains as simply as accurately as possible what the function does. And this should be a verb or some phrase containing a verb. And to run the function, we have to call the function. Use its name followed by round brackets. Actually, in Python, function as objects. Uh, so we can refer a function without calling it. We just use the function name without round bracket. So here, for example, we say var b equal to func a, and then we can call func a through var b. Okay, let's see the example here. Here we have def my function, which call my auto function, and then my auto function print hello. And here we call my function, right? And this file, because here when we call my function, it calls my auto function, and my auto function print hello. So that's why we get the output hello here. On the other hand, here we define my function, which is called my auto function, and then we call my function, but we haven't defined it my auto function yet. So that's why there's the error at line number 3, which traces back to line number 2, because at line number 2 we haven't defined my auto function yet. So we need to define function before we call the function. And this is the demo problem one. You may want to create function func a which print a message which is given a parameter. Like you can call function a like hello Python, hi Python, and then call the function and then assign the function object as a value to variable b without calling function. And then now call the function using variable b. And then the output of this demo problem one should be as hello Python, and then the next line is hi Python. Okay, next we're gonna look at input parameters. If we want to pass information into the function, and that information may be used inside the function, then we express this for information as a series of input parameters. In this slide, we have a function example as print sum, which accepts two input parameters a and b. And then inside this print sum, we compute the sum of a and b. So here, when we call print sum at line number 4, 2 plus 3 is 5. And when we call print sum at line number 5, print sum 2.0 and 3.7, and here we get 5.7. Okay, in Python, parameters have no declare type. We can pass any kind of variable to the print message function above, not just a string. And we can also use print sum function to add any two things. It can be like two integers, two float, or an integer and a float, or even two string. The advantage of this is that we don't have to write a lot of different print sum functions. Uh, so uh, here, but there's also like the drawback that we don't have the type, because maybe if the user provide types that we cannot perform arithmetic operation like sum, then that may be error. Okay, now what if we want to call math function? Then we need to import math module first, as shown in line number 1. So here we want to call square root function of math. So we call that function at math.square root 4, which we get 2. And we can also call math.power 2, comma 2, which means 2d over 2. So that's why we get 4. It's often that we want to use a function to calculate some kind of value and then return it to us, so that we can store it in a variable and use it later. And the output which is returned from a function is called return value. So we use the return keyword to define a return value. And in Python, a function can uh, only have a single return value, but that value can be a list or tuple. So in practice, we can return as many different values from a function as we like, because we just put many values in a list or in a tuple. So here, if we want to return multiple value, we just place several values after the return statement and separate it by commas. And then this will automatically be converted to a tuple. Okay, let's see the example here. Here, we have divide function which has two input parameters, dividend and divisor, and we want to return both quotient and remainder. So when we return, first we return value of quotient, and because we also want to return the value of remainder, so we use comma here. So when we compute divide 35 and 4, we get quotient as 8 and remainder as 3. Okay, and that's correct. And when we get the return values from the function, here we return two functions, so we can have two variables to accept those two values that return from function, or we can have like a tuple or an array. So we have result as the array, and we can get the first return value by accessing in the element at index 0, and that means we get the quotient at result 0 and get the remainder as result 1. So here when we call like divide 67 and 9 by 9, so here we get the quotient in result 0 as 7, and remainder at result 1 as 4. All functions return something, even though inside the function we may not have return statement. So if we don't have return statement in Python functions, the default return value is none, which is what the is set to be. So when a return statement is reached, the flow of control immediately exits the function, and any further statement after the return statement will be skipped or not executed. Okay, let's see the example here. So here, we go back to the function divide, and if the divisor is 0, then not divisor is true, right? So we return none. So here, when a is 4, b is 0, and we attempt to divide a by b, and when we print out the return value, we can see that it returns none and none. And yes, suppose that we find a function that just has print statement. uh, when we have the variable equal to the function, and when we call the function, when we print it, it will uh, print none, right? But why do we have hello here? Because when we call simple function, first it's gonna print hello, right? And then after that, it's gonna print the return value from simple func, which is none. Likewise, func2 also call be executed, and then print hello is executed. So that's why we see hello here. And here none is also returned. So that's why we see none here as well. Okay, so sometimes it's actually more appropriate to raise an exception instead of return a value like none. So if there is something wrong, we can raise with like exception, and then when we raise with exception, then there will be the error. So here we return value that the divisor cannot be 0, right? So that's why we see the message here that uh, attempting to divide by 0. But here, it's better to also handle this exception. Later on, we're gonna have the example about how to handle errors inside the function. Okay, so yeah, this is a better code. So in case that if we uh, expect that there may be error uh, in the code when we execute the function, we should use try and except to handle that exception. So here we want to multiply a with b, right? We can multiply numbers but not string. So in case that in the first example, when we attempt to multiply string with string, so we don't return the exception. We just simply return none. But that's not the best way to handle exception. The best way should also print out some useful message for the user to know what's wrong with that code. Okay, so yeah, there are also some demo problem too. That with the given function divide, I want you to learn how to improve the function to be better by handling exception appropriately. Okay, next we're gonna learn about the stack. So Python store information about functions which have been called in a call stack. Whenever a function is called, a new stack frame is added to the stack. So all of the function parameters are added to it. And as the body of function is executed, local variable will be created there. And when the function finish executing, its stack frame is discarded and the flow of control return to wherever you were before you call the function at the previous level of the stack. Okay, so let's see the example here. Here we have example.py, which has function say that accept name. And then inside the function, there's the print statement, print hello name. And here you can see that there's the error here because the input parameter name has E, but here this variable does not have E, right? So when we execute this example.py, that's why there's name error. Name NAM is not divided, but it will started from the code at line number 5, which say Michael, right? Because that's the uh, first line that the program will be executed. But then say Michael go back, right, to when we say Michael, it call this function, and then it will trace back that, oh, there's the error at line number 3. So when we use identifier, Python will first look for it on the current level of the stack. And if it doesn't find it, it will check the previous level and so on until either the variable is found or is not found anywhere and you get an error. So this why local variable will always get precedence over a global variable with the same name. Okay, and here Python also search the stack uh, whenever it handles an exception. First, it checks if the exception can be handled in the current function. If it cannot, it terminates the function and try the next one down until either the exception is handled or some level or the program itself has to terminate. And the testback you see when an exception is printed show the path that Python took through the stack. We can make a function call itself, which is known as a recursion. A common example is a function which calculates numbers in the Fibonacci sequence. The zero number is 0, the first number is 1, and each subsequent number is the sum of the previous two numbers. And whenever we write a recursive function, we need to include some kind of condition which will allow it to stop recursing. And in case in which the function doesn't call itself, in this example, that happens at the beginning of the sequence. The first two numbers are not calculated from any previous number. They are constant. Okay, let's see the example code here. So here we define Fibonacci function which accept n, right? And if n is 0, we return 0. If n is 1, return 1. Otherwise, return recursive function, which is Fibonacci n minus 1 plus Fibonacci n minus 2. So by doing this, then we can use Fibonacci to compute for any integer. So here, when the user enter 3, it compute that Fibonacci of 3 is 2. But if we don't write the function in the recursive approach, here we write it in iterative way, then we need to use for loop here. So here we initialize current and next to be 0 and 1. And then for I in range n. So range n will go from 0 to n minus 1, right? It will compute current comma next equal to so current equal to next, and then next equal to current plus next, and return current. So this also give the same answer. And there are also some example problem that you can solve to practice implement writing a recursive function. Okay, next we're gonna learn about default parameters. Sometimes there is a good reason to want to have two versions of the same function with different set of parameters. You can achieve something similar to this by making some parameters optional. To make a parameter optional, we need to supply a default value for it. Optional parameters must come after all the required parameters in the function definition. Okay, so let's see this example. So in this example, we have function make greeting, which has three required parameters, which are title, name, surname. But the last parameter is optional parameter, and it has the default value as true. So if formal is true, then it returns hello, title, surname. Otherwise, if formal is false, then it returns hello, just name. So at line number 7, we actually don't give the fourth parameter. And we can do that because that parameter is optional parameter. It has the default value true. So here at line number 7, we don't supply the input parameter formal, but we have the value of formal as true. So that's why we return as hello, Mr. Smith. On the other hand, at line number 8, we provide formal parameter value with false. So that's why we get hello John. So how default parameter works? So when we call the function, we can leave the optional parameter out. And if we do, the default value will be used. If we include the parameter, our value will override the default value. And we can define multiple optional parameters. Like in this example, we have two optional parameters, which are formal and time. And at line number 13, we call the function with only required parameter. At line number 14, we call the function with the uh, three required parameter and one optional parameter. While at line number 15, we call three required parameter and two optional parameters. And at line number 13, when we don't supply optional parameters, here formal value is true and time is none. And at line number 14, formal is false and time is none. But at line number 15, formal is false and time is evening. We have been passing positional parameter to all these functions. A tuple of values which are matched up with parameters in the function signature based on their position. But in Python, we can also pass value by using keyword parameters. Here with the keyword parameter, we can explicitly specify the parameter names along with values. So here in this example, we can see that we have keyword parameters. So here we have keyword parameters as the keyword name is title and keyword value is Mr. And here we can have both positional and keyword parameters, but uh, we um, actually in keyword parameters we can specify keyword parameters in any order. Uh, But if we have both keyword parameters and positional parameters, we need to call the function with positional parameter first. And then after we specify all positional parameters, then we can specify keyword parameters, like the example as this line number 21, where make greeting call with three required parameters. And then after that, we have keyword parameter time equal to evening. And in Python, we need to be careful when we use multiple types as default parameter value in function. If we intend to modify them in place. So here, when we define function add pet to list, and here we have uh, two parameters, pet to add to the list, and the second parameter is pet equal to empty list, and inside the function we say pet.append pet. So here um, because this pet the list is mutable, when we say list with cat, uh, it when we print list with cat we should see only cat, like, but uh, it's actually become the same list. So after we add cat, we also has add dog. So when we print both lists, it point to the same object, same list. So that's why we get the output as cat dog for both. So remember that although we can execute a function body many times, a function definition is executed only once, and that means that the empty list we create in the function definition will be the same list for all instance of the function. So what we really want to do in this case to create an empty list inside the function body. And this the demo problem 3 that you can practice with required parameters and optional parameters. Okay, next we're gonna look at star argument and star keyword argument. Sometimes we may want to pass a variable length list of positional or keyword parameters. So in that case, then we want to use star before operator name to indicate that there is a variable length tuple or positional parameters. And if we have available length dictionary of keyword parameter, then we use star star. And by convention, the parameter name we should use for tuple is args, which stands for arguments, and the name we use for the dictionary is kwargs, which stands for keyword arguments. So let's see the example here. Here we have defined the function print arguments, and here we have star arguments, and here we can call for each argument in arguments and then print argument. And then another function print keyword argument. Here we have two parameters, key and value, for each item of keyword arguments. And here when we call the function with star argument and keyword arguments, we can observe that we can call the function with any number of parameters. When we call 1, 2, 3, it also print 1, 2, 3. When we call 1, 2, 3, 4, it can also print 1, 2, 3, 4. And we can keep go on and on. We can call with 5, 6 parameters and so on. For keyword argument, we can also call with multiple pairs of key and values. Like the first call, we have two pairs, name and surname. And the second call of print keyword argument, we have only one pair, h equal to 10. So here we can vary the number of keyword parameters. And here we can also use star or star star when we call function to unpack a sequence or a dictionary into a series of individual parameters. Okay, so here we define my list as tuple, right? And when we say print argument my list, uh, because here we uh, have the star here, it will uh, unpack the sequence of list into individual member. So that's why we see 1, 2, 3 here. Okay, next, for print keyword argument, we also have star star keyword argument here. And here we define the dictionary with two pair, right? Name, uh, the name match with the value Jane, and surname match with the value Doe. So here when we print it out, we also see the these two pairs of values. Okay, we can also mix star argument and star star keyword arguments, but star argument and star star keyword argument must come after or other parameters, and star star keyword arguments must come after star arguments, and we cannot have more than one variable length parameter or more than one variable dict parameter. We can have only one star argument and one star star keyword argument in the same function definition. So this is the example of missing ordinary parameter with star argument and star star keyword argument. So here we have positional parameter first, and then keyword parameters, and then variable length parameter. And for variable length parameters, we need to have star argument first, and then star star keyword arguments. And this also is the demo the usage of star and star star, and also with the default value. And this demo problem 5, uh, here in this problem you're gonna learn how to use star argument in order to add any number in as inside the definition parameters. Okay, so next we're gonna look at error handling. So here you can see that here we use try except else finally to handle the error. Finally here will always be executed, and else is executed in case if there's no exception. And there are also some function design principles that we should learn. Uh, the first one is single responsibility principle example. One function should define do only one thing. And the second one is we should keep function small. Uh, so it should be executed for only minimal